So this is your pump handle. You inspire, it lifts up like that. That is the pump handle movement. Welcome to Physiology with Shakthi, and we're going to start with respiratory system from today. So we're going to start with the mechanics of respiration, basic muscles that are involved in respiration, what is involved in inspiration, what is involved in expiration. Now I know this is a very simple thing, but based on the MCQs that I put in Instagram over the last week, I realized a lot of you are making quite a lot of mistakes in such a small and easy topic. So get your concepts right. It will help you out throughout the respiratory system. So when we talk about mechanics of respiration, we need to understand what is involved in inspiration, what is involved in expiration, how that happens. So take a look at your rib cage. We got the sternum over here. We got the manubrium sternum, the body of the sternum, and the xiphoid process. We got the clavicle over here, and these in the dotted lines are the first 6 ribs. And beyond that, we got the 7, 8, 9, 10, and your floating ribs, which come from behind but do not actually attach to your sternum. So these are the rib cage structures that are present. Now we need to inspire and expire with the help of this. So apart from this, we got a muscle over here, which is the diaphragm. Now this diaphragm is a dome-like structure, as you know it. Just imagine that contractile force, when it contracts, it comes in and this dome structure becomes a flat structure like this. So that is what contraction of the diaphragm does. So when we talk about inspiration and expiration, ultimately it's all depend upon what it has to do on the rib cage. So just imagine this closed space. This is a cavity and this is a closed cavity. No connection with outside. Now I'm going to pull this so that the volume increases. I pulled it on either side so that the volume increases. According to Boyle's law, pressure and volume are inversely proportional. So when I increase the volume in a closed space, so consider it's almost like a vacuum, and we are opening up and increasing the volume. When the volume is increased, what will happen to the pressure? Pressure will drop when the volume is increased. So in that closed cavity, because of inspirating muscle, chest wall went outside, diaphragm went out, increasing the volume inside. When the volume was increased, pressure dropped. Negative pressure developed inside the alveolus. So a negative pressure developed inside the alveolus, and that would result in a negative suctioning pressure, because of which air will now come in. Okay, so that is what I am telling you. We got the inspiratory muscles, which does something like this. On the other hand, the expiratory muscles, they contract in such a way that they push it. Instead of this, they push it down. So when it pushes and the volume decreases, the pressure increases, and when the pressure here builds up, it goes out. So unlike the chest cavity, your tracheobronchial tree is not a closed space like this. Over there, that is a open space like this. So pressure changes here will be based on this, but that pressure changes when it goes to your alveoli, and the intra-alveolar pressure changes like that. Based on that, either if the pressure is higher, it goes outside. If the pressure is lower, it comes inside. So that is ultimately what actually happens. So for that, we need to understand which are the muscles that are involved. Now when we talk about inspiration, the primary muscle for inspiration is your diaphragm. 70% of the tidal volume is 60 to 70% of the tidal volume comes to be accounted by the diaphragm. Now I have read some other textbooks which mention that the remaining 20 to 30% is accounted by muscles like the parasternal muscle, the parasternal intercostal, and the scalene muscle. So I'm telling you this for your information. I don't think questions from that will be asked, but you just need to understand that diaphragm is your primary inspiratory muscle, especially when you talk about tidal ventilation. So when we talk about respiration, there is a tidal ventilation and overdrive ventilation. So tidal is a eupnea, that is normally how I breathe. This normal breath, that is eupnic breathing. On the other hand, if I want to go into an overdrive mechanism, that inspiration, that expiration. So in all these stages, the muscles that are involved are different. But when you talk about tidal ventilation, you have to understand that diaphragm is a primary muscle. 30% of the tidal volume is accounted by the diaphragm. What about expiration? Expiration is a passive process. It does not use any muscles, especially when you talk about the tidal ventilation. So normally I breathe in, diaphragm is acting. I breathe out, no muscle is actually acting. What is happening is this diaphragm which went inside simply recoiled back. Nothing else happens. So in normal respiration, this diaphragm in tidal ventilation can go down up to around 1 to 2 centimeter. On an average it is 1.5. So 1 to 2 centimeter or on an average 1.5 centimeter is how much your diaphragm can move during your tidal ventilation. But deep inspiration, the diaphragm can go all the way down, and that can account for up to 7. So 7 to 8 centimeter. So tidal ventilation, diaphragm can move up to 1 to 2 centimeter. Overdrive inspiration, deep inspiration, it can go up to 7 to 8 centimeter. So that is the importance of diaphragm, and diaphragm acts and increases the volume inside the thoracic cavity. So that is the primary inspiratory muscle. And I mentioned how the eupnic expiration is pretty passive. This simply recoils back. It comes to this level in tidal ventilation and it recoils back. So no other muscles are involved. Now when you talk about deep inspiration, what are the other muscles that come into picture? So this is one thing that happens. It goes till 7 to 8 centimeter. Apart from that, certain other muscles come into play. So there is external and internal intercostal muscles. We'll keep it aside for now. Later when we talk about expiration and inspiration, we can compare them and see what happens. So I'll go to the accessory muscles. Apart from this diaphragm and the intercostal muscle, we have other accessory muscles. So I'm inspiring a little more. Now this sort of effect towards the end of overdrive, especially that is when all the other muscles are recruited, especially these accessory muscles. The first among them that you need to understand is two muscles called the scalene muscle and the serrati muscle. We got the first two ribs over here. So from here, the scalene muscles acts on the first and the second rib. And what does it do? It pulls it up. So it pulls it up like that. We know the presence of a muscle called the sternocleidomastoid. There's a sternal head and a clavicular head and attaches to your mastoid process. So that is your sternocleidomastoid. So that also pulls it up. So we got the sternocleidomastoid, we got the scalene muscle, and we got the serratae muscle, serratus anterior, anterior serratae. They are involved with the first 6 ribs. So they are like this. They kind of come and pull it up like this. So the first 6 ribs, this is your serratus anterior. So we got the scalene muscle which pulls up, the sternocleidomastoid which again pulls up, the serratus anterior which pulls outside, and this is involved in the upper part of your chest wall. We got the scalene muscle, first 2 ribs. We got the sternocleidomastoid which is involved in pulling up the sternum as well as the clavicle. And we got the serratus anterior, the first 6 ribs. So this sort of movement, because of this, will be seen like this. It will be sort of like this. See, your sternum is there and the sternum is lifted up by this, and scalene is pulling up your first 2 ribs, and serratus anterior is also pulling it out like that. So ultimately this kind of movement is what is called the pump handle movement. Just imagine there's a hose coming out like that, and this is the handle, and someone's pushing it like this to get water. So this is your pump handle. You inspire, it lifts up like that. That is the pump handle movement. So that is for the upper part of the rib cage. We got the sternum, we got the first 2 ribs, we got the serratus anterior. These are the pump handle movement. So apart from that, especially towards the later stages, you got activity of these muscles as well. So that is what is called a bucket handle movement. So just take a look at your bucket, and we're gonna put a handle like that. We'll put 2 handles like that. See the similarity over here? Now imagine you're lifting up the bucket, and this kind of moves from here and goes a little more further beyond it. See that? So from this point it went to this point. From this point it went to this point. So this sort of movement is what you see here. Over here you see a pump handle movement. Over here you see a bucket handle movement like this. Got it? Yes. So bucket handle movement is the lower ribs. Pump handle movement is the sternum with the upper 6 ribs. And often your diaphragmatic movement can sometimes be called piston pump movement. I seen one question based on that in some MCQ. Okay, so that is your piston, a piston pump. So this piston diaphragm, it comes down like this, and along with that the diaphragm moves. So that sort of movement is a piston pump movement. So bucket handle movement is for the lower ribs, pump handle movement is for the upper ribs and the sternum, and piston pump movement is your diaphragmatic movement. Are we clear with that? Okay. Now apart from this, we also got your trapezius, which comes to this side part of the clavicle like that. Can you see that in the diagram? Yes. So that is your trapezius, and you also got the latissimus dorsi. So towards the end of inspiration, that point you can actually feel your latissimus dorsi also acting. So these are the muscles that are there. Apart from this, we got another muscle which is your ala nasi. This ala nasi is how you're going to pinch up your nose to deeply inspire. So this activity is the ala nasi. So these are all your accessory inspiratory muscles. The primary inspiratory muscle is diaphragm. Don't forget that. primary inspiratory muscle is diaphragm. Very simple thing, I don't know. Some people still get confused with it. So the primary inspiratory muscle is diaphragm. And apart from that, we got the sternocleidomastoid, scalene, trapezius, serratus anterior, especially acting over here. And we got the buccal movement over here. And we got the latissimus dorsi also and the alanus. And apart from this, these other muscles which are there, these are your intercostal muscles. So that is what actually makes this and this also move. So that is where your intercostal muscle come into play. Now, one thing I used to get confused was to understand which is for inspiration, which is for expiration. External intercostal and internal intercostal. Which is for inspiration, which is for expiration. That was one major confusion I had. It's very simple. External. It pulls it outside, external. And when the chest wall is pulled outside, what should it result in? Inspiration. So external intercostal acts to pull it out, and that is for inspiration. Internal intercostal pushes it inside, crowds the ribs together, and that is expiration. External intercostal is inspiration, internal intercostal is expiration. So take a look at this diagram. It goes like this, kind of like a crisscross among them. Just take a look at the ribs over here. I'm gonna take it on the other side. Right? These are the ribs that I had seen earlier. Now, the external intercostal acts in such a way that this pulls it outside like this. So the muscle kind of comes from here and pulls it in this direction so that it pulls it outside. On the other hand, when we talk about the internal, that kind of pushes it inside like that. So external intercostal pulls it outside, internal intercostal pulls it inside. So whatever pulls the ribcage out is for inspiration, and what pulls it inside is for expiration. Are we clear with that? So we got the internal intercostal, we got the external intercostal. So for inspiration, what have we understood so far? Primary muscle in tidal ventilation is diaphragm. When we talk about expiration, the muscle are not involved. It is purely a passive process because of the recoil of the diaphragm. And after that, we got inspiration and expiration in overdrive mechanisms. So in overdrive mechanisms, we got the intercostal, which is external intercostal for inspiration. And we got the other muscles that are involved, which are the accessory muscles. We got the scalene muscle, we got the sternocleidomastoid muscle, we got the trapezius, we got the anterior serrati, we got the latissimus dorsi, and we got the ala nasi. So these are all the accessory inspiratory muscles that are present for overdrive ventilation, inspiration especially. And when we talk about expiration, we know eupneic expiration is passive process. Tidal expiration is passive process. But in overdrive mechanism, we already got one muscle that is involved, which is your internal intercostal. Apart from the internal intercostal, there are other muscles which are involved, which are especially your abdominal muscles. So we got your recti muscle. Just take a look at the recti muscle over here. So this recti muscle, which comes like this, and it kind of has attachment to your xiphoid process, this parts of this 5, 6, 7, 8, like this. So that is your recti muscle. And apart from the recti muscle, we got the transverse abdominis. The name indicates what or how it acts. It is transverse. So this is upright vertical, that one is transverse, and its action will push the stomach inside. We got the abdominal recti muscle, we got a transverse abdominis, and to the side, this movement that we do, that is the oblique muscles. So towards the side like that, that is the oblique muscles, the internal and external oblique. So these are further involved for expiration. So normal expiration is passive. Expiration, intercostal muscles are acting, which is the internal intercostal muscle, and further on your abdominal muscles acting, which is the abdominal recti, which is the transverse abdominis, which is the internal external oblique. Now, once all these muscles are clear, we'll take a look at what happens in the larynx as well. So we inspire, and at the end of inspiration, before expiration begins, or at the start of expiration, we do not want any foreign body particles that are lodged somewhere nearby to enter inside. That will lead to it going inside the trachea, and that is the problem. It can lead to infection, pneumonia, all these things. So to prevent that sort of foreign body entry, at the end of inspiration, when expiration is beginning, that is when the adductors of the larynx act. So inspiration, abductors should act, and during expiration, at the beginning phase of expiration, it adducts slightly, not completely. Complete adduction means you can't expire. So it kind of adducts, not completely, partial adduction, and that will result in the foreign bodies being prevented from entry, and after that your passage happens. So that is the involvement of the abductors and adductors of larynx when we talk about respiration. So that is about mechanics. So when we talk about the questions in this, the pump handle, piston pump, and bucket handle, that is one question. Next question, internal and external intercostal. You need to know which is for which. And the accessory muscles. So one among them can be put in the option, and they can confuse if you don't know it properly. And then is the diaphragm. This is another question. 1 to 2 centimeter in tidal and 7 to 8 centimeter in overdrive inspiration. And apart from that, and then the next question would be about the muscles of expiration in the overdrive expiration. And also important to know that passive expiration happens in tidal ventilation. Right? The expiration process is passive. There's no active involvement of any muscles. Okay, and just so that you don't get confused, in case this comes in one of the options, there is a muscle called the triangularis sterni muscle. This is a triangularis sterni muscle. Now, this triangularis sterni muscle seems to be involved in expiration. So it's like a triangular structure that is there between the ribs, and that is involved in expiration. Even I read some books and articles mentioning its role even in unique expiration, but we'll just keep that aside. I don't think it'll be asked. It hasn't been asked so far. I don't think it'll be asked. But in case it comes up, I just wanted you to stay informed. That's it. There's something called triangularis sterni, which is also involved in expiration. So that is about the mechanics of respiration. It's a very simple thing, and it's important that you understand these basic concepts so that we can progress further in respiratory medicine. If you like the content, please do subscribe, and if you think it might help someone else, please do share it. And thank you.